welcome back. Alright, so for our today's lesson, I'm going to talk about phase diagram. So phase diagram is a spatial diagram which is the plot of pressure versus temperature, which shows the region of solid, liquid and gas in the graph. Alright, these three phases, and in the same time there is a curved line which shows the equilibrium line between solid and gas, solid and liquid and gas. And from the same phase diagram, we're going to discover two important points, which is triple points and critical points. So I'm going to explain in details about this phase diagram. Please make sure you completely focus on my lesson video, because this one is a very interesting topic. Okay, so by the end of this lesson, okay, you're going to understand the concept of phase, okay, how to determine the different type of phase and what kind of mixture is present, either homogeneous or heterogeneous. Alright, so secondly, you're going to be able to understand what is triple point, what is critical point, and the definitions lies about that. And you're also going to understand about phases that lies in every region. Okay, three regions, three different phases, and what are the phases that lies in equilibrium along the curved line. Alright, okay, so next, from all of this important information, you're going to learn how to describe the phase changes that happen to a molecule. Okay, either the phase changes happen at constant temperature, various pressure, or at constant pressure with various temperature. And from the curve of in the phase diagram, okay, you will see a slope or a straight line represent like a gradient. Okay, so there are two types. So you're going to learn what is the difference between these two. Okay, so let's look at phase. Okay, so in this world, we have these three kind of phase: solid, liquid, or gases, where a mixture is consisting of either the same type of phase or different type of phase. Okay, for example, okay, the phases need to have a clear boundary between each other. Okay, if it's in a heterogeneous mixture, but if it is a homogeneous mixture, okay, we cannot separate the different phases that is present or the same phases that are present. Okay, if let's say you are still unclear about phases, let me show you one simple example. This is a cup. Okay, a cup filled out with water. Okay, inside this water, these are ice. Okay, so these are cold water. Okay, so this ice is in a solid form, so we name it as solid phase. Okay, whereas the liquid all over the container or in the cup, this is liquid or water. Okay, this one is in a liquid phase. Okay, so you can see clearly there are ices and liquid in this cup. Okay, since you can see clearly the difference between these two phases, we name it as heterogeneous mixture, which made up of two phases, solid and liquid. Okay, so let's look for homogeneous mixture. Okay, I have an orange juice, so orange juice, and then I'll try to dilute my orange juice. Okay, so I add on water, so it's actually one liquid phase, water, and another one liquid phase, which is your orange juice. So in the same mixture, I have two phases, of the same type, which are liquids. Okay, then I use a spatula. Okay, I use a spatula and I stir the mixture. At the end of the day, I'm going to get a one whole mixture in one color, which is your diluted orange juice. Since I cannot show clearly the difference between my orange juice and water in the final mixture, so this one we name it as homogeneous. Okay, this homogeneous mixture is made up from two liquid components of a different types but in the same phase. Okay, so now do you have a clear understanding about heterogeneous and homogeneous mixture? Okay, let's try a simple exercise. Okay, so the first picture, okay, this one is your first picture, is an ocean. Okay, an ocean that has undergoes an oil spillage over the entire ocean. Okay, so you have to find out how many phases are present. Okay, so the first one is ocean water. That is the first phase, which is your liquid phase. Okay, one. Okay, secondly, oil. This oil spillage is also a liquid phase as well. So two liquid phase. And then we have here a fisherman. So fisherman consider a human. We can consider it like a solid form. Solid phase. And a motorboat is another solid phase. So two solid phase, two liquid phases. And we can see clearly the difference between the oil, the ocean water, the motorboat, and the human or the fisherman. So, two phases, so two solid phases, two liquid phases made up a mixture. And this one, since we can see clearly the difference between all these four, we name it as heterogeneous mixture. Okay, secondly, let's look at this pizza. It looks yummy with the pepperoni. Okay, I can see pepperoni here. Okay, this one is the green capsicum. I don't like green capsicum. It is yucks compared to yellow and red one. Okay, so this one is the cheese and this is the pizza bread. Okay, for your pizza, it's made up of green capsicum, pepperoni, cheese and pizza bread, which are all considered as solid phases. Solid, okay, solid and solid. But you can still see clearly where is pepperoni on the pizza, where is the green capsicum on the pizza, okay, unless it's been covered by cheese, but still when you remove the cheese, you still can discover where is pepperoni, where is the green capsicum, and you can definitely clearly see the pizza bread. Okay, even though it's all made up from the same solid phase, four different solid phase type, okay, still there is a clear boundary between them and we can see clearly the difference. So this one is a heterogeneous mixture too. Okay, and the third example, okay, so this one is showing the air composition. Okay, the air that we breathe in every day is actually made up of argon, group 18 or inert gas, oxygen 21%, nitrogen gas is the dominant 78%, with some small proportion of other types of gases. Okay, so all of these are in the gas phase. Gas, gas, and gas. Okay, 4 different gases, or might be more, okay, if this small proportion is made up of many more types of gases like chlorofluorocarbon that we have, or hydrogen gas, or perhaps carbon monoxide or methane. Okay, but all of these gases are from the gas phase and we cannot see the difference between them. Can you spot any nitrogen gas on the air? Can you discriminate between argon gas and oxygen in the air? No, we cannot see it. We cannot determine the difference between them except unless we do an experiment to discover which one is which. So since we cannot see clearly the difference between them, so this one is a homogeneous mixture. Okay, move on to the next part. Okay, second example, okay, if we are making a coffee, okay, so this is a coffee water. How do I spell coffee? It's completely wrong. Sorry, it should be C-O-F-F-E-E. Okay, and then this is a milk and sugar. So definitely this is a fresh milk, not an evaporated milk, because we add sugar after that. So if it's an evaporated milk, it will become too sweet. Okay, so from this mixture, liquid and sugar is a solid. So three different phases. Okay, three phases. It's going to make homogeneous mixture and heterogeneous mixture. So it depends on the temperature of your coffee water. If it's cold, then you're going to end up with the heterogeneous mixture, because we cannot mix the sugar very well. Instead of having a dissolved sugar, we're going to have a visible lumps of milk and sugar. Okay, so the mixture does not dissolve completely, does not combine well, so end up become a heterogeneous mixture. But if the coffee water is hot, it has the ability to dissolve both milk and sugar very well. So all the three ingredients blended together becoming a homogeneous mixture. Okay, I hope I already give enough examples for you to understand the difference between phases. Okay, so the difference between homogeneous and heterogeneous mixture. So we're going to go to a more serious issues and the phase diagram. Okay, so we're going to interpret the phase diagram. Okay, so this is your phase diagram. Okay, so this phase diagram is a plot of pressure versus temperature, and in each phase diagram you will completely see the solid region on the left side, followed by the liquid, okay, and the vapor phases or region. Sometimes the vapor is being substituted with gases. Okay, and in the same phase diagram, you're going to see this curved line, okay, curve, but this one between the solid liquid, this one is a straight line. This one we name it as slope. Okay, so the slope and the curve is actually, we name it as equilibrium line. Okay. So you can see the three different regions that is present in your phase diagram: solid, liquid, and gas. Okay, and then you're going to determine the triple point and critical point. So you see the equilibrium line, okay, between solid and liquid, solid and gas, and liquid and gas. Okay, so what is triple point? So triple point is the point when all the phases, solid, liquid, and gas, lies in equilibrium. Okay, so at this triple point, solid is in equilibrium with liquid and in equilibrium with gas. Okay, so equilibrium means we're going to use this arrow, reversible arrow. So solid, liquid, gas. Okay, where critical point is the maximum temperature a gas can be liquefied. Okay, let's do another example. So what phases are present in region A? So solid, B is your liquid, and C is vapor, or mostly we will write it as gases. Okay, next, what phases are in equilibrium at point A? So A is in between solid and liquid, therefore it is solid and liquid in equilibrium. So we're going to write as in equilibrium with liquid. Okay, if in the exam, please make sure you don't write as, you need to write the full name, solid and liquid. Okay, so B is located between liquid and vapor. So this one is liquid in equilibrium with gas. Okay, please make sure to use reversible arrow to represent equilibrium. Okay, C, point C, where is C? Okay, so C, no, it's not C. Okay, so C is in the solid region. So this one, the answer should be just solid. Okay, so it does not have any equilibrium between 2 or 3 different phases. Okay, D is your triple point. So this triple point, as we said before, triple point is a point where all the phases lies in equilibrium. So at D, we have solid in equilibrium with liquid and in equilibrium with gases. Okay, whereas at E is your critical point. So above E, so E is the critical point where it is the maximum point a gas can be liquefied. Above E, no more liquid can be liquefied or no more liquid can be changed into gas. So all components will become entirely gas, okay, above E. So at E, we still have liquid and gas, so L in equilibrium with G. Okay, whereas at F, above critical point, only gas is present, so this is just gas. Okay. Okay, so question, state the value of pressure and temperature for triple point. Okay, so this is the triple point. Okay, so you look at the temperature, which is on your X line. Okay, so this is your X. Okay, so triple point we have here, it's 0.0098 Kelvin, and at this temperature the pressure of the substance is 6.0 times 10 to the power of negative 3 atm. Okay, so you look at the Y value. Okay, critical point. Okay, this one. Okay, so the temperature is this one, 374.4 Kelvin, and the pressure is 217.7 atm. So let's say if you try to write down it in the coordinate form, like in the mathematics, okay, so we're going to write the X 0.0098 Kelvin, and then 6.0 times 10 minus 3 atm. Okay, so this one, if it's in the coordinate form, 374.4 Kelvin and 217.7 atm. Okay, what about normal boiling point? Okay, all the substance in this world will boil at normally in 1 atm. So now let's look at 1 atm. What is the temperature? So you go across this, draw a straight line from 1 atm. Okay, so boiling is a process to convert liquid to gases. Okay, so you have to look in between the liquid and gases equilibrium line, and at this point it intercepts the X value at 100 degrees Celsius, so 100 degree K. Okay, so this one is between solid and liquid. This is for melting and freezing process. Okay, so depending on which one is which. So if you start from a solid to liquid, it's a melting process. But if you start from a liquid to a solid, it's a freezing process. Okay, so between this liquid and gas equilibrium line, we have boiling. Okay, if it's liquid to gas, and condensation. Okay, if it's from gas to liquid. Okay, and between this one, okay, solid and gases equilibrium line, this is for sublimation process. With sublimation process is a transition from solid to gas, and deposition process if it's from gas to solid. Okay. Okay, so this one state the phase changes starting from A when the temperature has been raised at constant pressure. So constant pressure, so where is your A? Okay, let's say I put your A to be here. So this is your A. Okay, when the temperature has been raised at constant pressure. Okay, I don't want this to be A. Let's move to a different, because you will only see gases. Okay, let's put A to be here. This is your A. Okay, we're going to raise the temperature at constant pressure. So draw a horizontal line. Okay, so that is, okay, so we start from solid. So this is how you write the phase changes. Solid, arrow to duplicate to shows the transition process. Okay, so it touched the equilibrium line between solid and liquid. So solid in equilibrium between liquid. Please make sure you use bracket to show equilibrium and reversible arrow. Okay, after passing through the solid liquid equilibrium line, it moves to liquid region. Okay, and then it touches again the liquid gases equilibrium line. So liquid gases equilibrium line, and continue. Okay, raise the temperature since it doesn't state the maximum temperature it reaches, so we just assume it's going to till the end of the phase diagram, which is here. So from liquid to gas equilibrium, it ends up as a gas. So this is how you write down the phase changes. Okay, but in a one straight line. Since my space is too small, I cannot write it in one straight line, so I have to go downward here from liquid to liquid gas. Okay, hint, you need to make sure you use reversible arrow to show equilibrium. And then if it's two different phases lies in equilibrium or three, use bracket to separate them from a phase that exists singly. Okay, let's look at another example to understand about the phase changes on how you can write a good phase changes process. So state the phase changes starting from B when the temperature has been, okay, when the pressure, okay, typo here, when the pressure has been raised at constant temperature. Okay, so let's start from, this is your B. Okay, this is your B. So at this temperature, okay, straight away, okay, draw a straight line vertically. Okay, so from point B, which is in the gas phase, okay, after passing through the gas phase, it hits the liquid gas equilibrium line. So gas liquid in equilibrium. Okay, and then it ends up as a liquid. Okay, so that is the phase changes starting from B when the pressure has been raised at constant temperature. Okay, okay, state the phase changes for transition from C to D. Okay, so let's say the C is here and D is here. So how can we describe the phase changes? First, draw a line that connecting between the 2 points. So I have C and D, I draw a connecting line. Okay, so it start from C, so start from here. So C is a solid. Okay, then in a transition, it counter with the solid liquid equilibrium line. Okay, so from solid liquid, now it enters the, okay, so from here and then it hits here, and then your liquid. Okay, after entering the liquid, now it passed through the liquid gases equilibrium line, and at point D, it ends up as a gas. Okay, so these substances undergo a process of solid to liquid, that means it's a melting. And from liquid to gas, this one is boiling. Okay, clear? Okay, another one to try. State the phase changes for the transitions from E to F. Okay, so let's say I start here with E, and then this one is F. Okay. draw a connecting line between these two. Okay, so E to F. Okay, at E, it started with in a gas phase. Okay, then it reached this triple point. So gas in equilibrium with liquid and in equilibrium with solid. Okay, then it enters the liquid phase after passing this through triple point and continue until F is still in the liquid form. So these are the phase changes when the substance undergoes a transition from point E to point F. Okay, isn't it simple? It's just simple, isn't it? Okay, so for your information, there are two types of slope that is present. So slope is referring to white line. So slope is referring to between solid and liquid line. So this one and this one. So we have two types. Okay, so this phase diagram of water and carbon dioxide, you need to memorize how does it looks like, what is the triple point and what is the critical point. So you need to know how to draw these two phase diagram. It's very compulsory. Okay, so in the phase of diagram of water, you can see this solid liquid line or your slope is slanting to the left. So slanting to the left. So because of that, we name it as negative slope. Okay, whereas in your phase diagram of carbon dioxide, even you can't see it clearly, but actually the slope is slanting a little bit to the right. So slanting to the right. Okay, so this one we name it as positive slope. Okay, so we have negative slope and positive slope. So what is the difference between these two? It's not just about the drawing. There is a hidden meaning between these two different type of slope. Okay, so let's look for phase diagram of water which it have negative slope. So if there's negative slope, okay, so you can see the water region is more dominant in size compared to your solid region, which is very small. So this one, it shows that the water has a bigger density, okay, is denser. So water is denser compared to your solid. Means our water prefer to be in liquid form compared to in solid form. Okay, so that one is the first. Solid is less than that is liquid, or you can write it in a different way like this. Water is denser compared to solid. And secondly, it relates to the melting point. Okay, so melting point is a process of solid to liquid. So how are you going to see this? Through this line. So this equilibrium line, okay, represent melting process. Okay, so equilibrium line here represent melting process. Okay, so if it's a negative, so it shows that the melting point decreases with increasing pressure. Okay, as you can see from here. Okay, so this line is slanting to the left, so temperature is getting smaller at higher pressure. So smaller T at higher P. So means melting point decreases with increasing pressure. Okay, so indirectly from this phase diagram, we believe that since ice or solid is less than water, that's why when we are putting ice in a cup of water, we can see the ice floating instead of sinking in the water, because solid ice water is less dense than solid. Ice water is less dense compared to its liquid. Okay, so this one is for negative slope. Let's look for the positive slope in the carbon dioxide phase diagram. So this one is the positive slope. Okay, so positive, this slope represent melting process. Okay, so you can see it's slanting to the right. That means temperature increases with increasing pressure. So your melting point increase with increasing pressure, and you can see the solid region is larger size compared to your liquid. So solid is more dense than its liquid, or liquid is less dense than the solid. Okay, and this one, positive slope is common for most compound on earth. Most compound like iodine, and other type of gases have positive slope. It means the melting point increases with pressure, and its solid is denser than liquid. Okay, so negative slope is a special cases for water. Okay, so types of slope present will determine which phases between solid and liquid is more denser or is denser. And secondly, it also shows you about the melting points. Either the melting point increases with increasing pressure value or decreases with increasing pressure value. Okay, let's do a simple exercise. Write down the stats of pressure and temperature for each triple point. Okay, so triple point is at point C. Okay, so write down at C the temperature is 114.1. So 114.1 degrees Celsius. And at this temperature the pressure is 0.112 atm. Okay, for the critical point, so critical point is here. Okay, see where I put a round circle. So it's 546 degrees Celsius. Okay, and the pressure here is 115 atm. Okay, next, write down the phase changes that takes place for the following cases, A to B. Okay, how to do this? Draw a line that connecting between these 2 points. So from A to B, okay, solid, and then it touched the equilibrium line between solid and liquid. So solid in equilibrium with liquid. Okay, and then it goes to liquid, and then go to another equilibrium between liquid and gas, and finally as a gases. Okay, I write it in the short form because my space is limited. Okay, so from point B to D, okay, draw a straight line connecting between B and D. So from B, it's in the gaseous phase, and then it touched the equilibrium line between gas and liquid. So bracket gas in equilibrium liquid, and end up at point D is a liquid. Okay, A to C, then to B. Okay, so draw connecting point between A to C. So from A to C is from solid. Okay, and then it touched the C is your triple point. So solid in equilibrium with liquid and equilibrium with gases. Okay, and then from A to C, then to B. Okay, draw B. Okay, so your B. Okay, so it goes straight away to gas. Okay, state the type of slope that is present and explain what does it mean in the term of density and melting point. Okay, so your slope here is slanting to the left. Since it's slanting to the left, which one is it? Is it negative or positive? So it is negative slope, correct? Okay, so negative slope, what does it mean? Okay, we have solid region which is smaller than liquid. Okay, that means in terms of density, liquid is denser than solid. Okay, and in the terms of melting point, it's slanting to the left, so you can see its point, the temperature is getting decreases as the pressure increases. Okay, so melting point decreases with increasing pressure. Okay. Okay, so that's all for today. Okay, don't forget to check out the exercise that I already attached to you in your Google Classroom, which will appear on our third hour tutorial for this week. Okay, try to answer that phase diagram exercise. I hope you guys can score 100%, and good luck in your study for online learning for until the end of the semester. And please make sure to revise on your practical tests this coming Wednesday. Thank you for watching. Bye bye. Take care.